Hello, I'm Jinju Wang. In today's video, we will have a walkthrough and understanding of Luto's file structure. Luto has four primary parts, which are data prepare, data process, solver and simulation, report, and tools. In the first part, we will introduce the root directory of the Luto model. We will introduce the root directory using VS Code. Here, we first open a VS Code software. In this interface, we will hit the bottom left, this little icon, to connect to WSL. You can choose to connect it to a Linux server. The operations are similar. When we connect it to a WSL, here in the Explorer icon, we will choose to open a folder. Click Open the folder. In the previous steps, we have created a Luto capitalized directory which stores the Luto code, and all the Luto code was stored in this Luto-2.0 subdirectory. Let's choose this directory and hit OK. Now, we can see that all the Luto files appears in the left Explorer panel. Let's walk through them one by one. The first directory is docs. It includes some guidance, some documents of how to use Luto. The first one is how to deploy Luto on HPC clusters. The second one is commodities. This is the supporting document for some of the Luto's assumptions. Third one is Luto 2 summary and statistics. This includes the general guideline, the mathematical modeling, and the high-level developing of Lutos. And in the last two are rich format text. The first is PDF version of the Luto summary. The next is the TEX version of Luto 2 summary. The next directory is input. Right now it is an empty directory. During the processing, we need first to clean up all the raw data, and the raw data will be transformed and placed in this input directory. The third one is the Luto directory. This is the core. This is where all the core data sit on. You can see it has a lot of Python files and subdirectories. We will get into this folder later on. Next is the output folder. It is also currently an empty directory. During the processing, Luto will output the result into this folder. Up to next, this is a git ignore file. In this file, we can say it ignores something. That means during the process or update of Luto, all those files will not be tracked in the vision history. Next is the citation file. This represents how Luto is wished to be cited, just like an article journal. It has some authors and their contact informations that represent a way to formally present Luto's citation information. Next is license. Luto uses a GNU open source license to give it a lawful copyright. Generally, Luto allows for an open source use of the code. Next is the pyproject.configuration file. This is the file for developers to test the Luto functionality, which should not be important to any user. Next is the README Markdown file. In this file, it includes some of the information we want to show publicly, to show how people should understand or cite this file. The Markdown file looks a bit messy here, but when we get to the Luto's web page, we can see this is the correct format of the Markdown files. It includes some of the information we want to show publicly. At last is the requirements file. In this file, it includes all the necessary Python packages that Luto requires to work on, including NumPy, Pandas, etc. Please note, some of the packages can only be installed with pip, for example, Groovy, NumPy Financial, and the tables, whereas all the packages above can be installed with Conda. This is the general look of the root directory. In the rest of the tutorial, we will focus on data preparation of Luto module. Let's go back to the Luto's file structure. The data preparation lives in Luto folder, and it is mostly within this dataprep.py file. Scrolling down, we can see it is nearly 1,000 lines of code, and if we go from the first few lines, we can see most of the lines are working on reading static data. For example, here it is copy data from one path to another path. And here we can say it's using a read functionality to read the data. And upper below, we can say it is reading some Excel, reading some HDF. And upper below, we can say it is formatting the data by doing some simple formulations. Reading the data line by line could be a challenge, so we have prepared a link that shows the general logic of the data preparation, which we can find in Luto's homepage, and in the documentation section we can find the link. Click the link will lead us to the overview of the data preparation code of its diagrams. Let's have a broader view of what the preparation is doing. So the first thing they have done is just read raw data in this block, just to simply read data into memory. And to a bit of right, those are more involved with transition cost. What is transition cost? For example, if a farmer plants some trees or cultivate some apples in the first year, but he transformed the apple into leasehold grassland in the next year, that will incur some transition. So this is all the variables, including how this transition going to happen. What is the cost? What is the revenue? The cost is not just mandatory, but it also includes some cost in biodiversity opportunity, the cost of water, etc. Moving a bit to the bottom, here we can see some of the topics. The one process water, the one link water with region. For example, if we want to calculate the total water consumption inside within a region, we need this process. What comes next is the economic data for both for crops and livestock. And even further is the greenhouse gas emissions for crops and livestock. That are some of the key input data for Luto. For example, by reading the crop table, we can get 69 million rows of records. And each row is a 1 kilometer by 1 kilometer grid inside a map. And each column is an attribute of the given grid cell. For example, if the third pixel is an apple, this value should be 1 or something. And further to the next, this is the agriculture economics for livestock. In the same way, each row is a 1 kilometer by 1 kilometer grid. Here we can see some different columns represent the economic values. For example, F1, Q1, AC. I can recognize AC is the area cost. For example, if we want to feed some sheep or some of animals inside this grid cell, how much we should pay for each hectare. It essentially is how much Australia dollar per head of sheep or per head of beef, etc., etc. So in this gigantic table, it includes all the information for the revenue to raise some sheep or beef. In similar way, this is agricultural greenhouse gas table. In this table, we can see that each pixel, we can see its greenhouse gas emissions per kilogram per hectare. And it was further divided by different categories. For example, this pesticide used emit some greenhouse gas, etc., etc. The key takeaway is we converted all record into a table format, and for each row is a cell, 1 kilometer by 1 kilometer grid cell. For each cell, we give it a cell ID so that each grid cell will have its own identity. We use this identity to link all data. So that's how we merge or link all data and process them, convert them into the shape, into the format we want. Okay, this is the tutorial of today. We have a walkthrough of the root directories, knowing the key files of the root directory. And we have another quick walkthrough of data preparation module, which linked all data by its cell ID. In the next tutorial, we will have a quick walkthrough of the data process module.